For 40 years, staying connected has meant staying within reach of a cell tower. Direct-to-device satellite communications break that assumption. For the first time, an ordinary smartphone with no dish, no special antenna, and no dedicated handset can connect straight to a satellite in orbit. In the next 5 minutes, we will cover what D2D is, why it matters, and how the leading systems actually work. Start with the problem D2D actually solves. Building a cell site takes power, backhaul, physical access, spectrum, and enough subscribers to pay for all of it. So coverage follows people and money, leaving oceans, deserts, mountains, and wilderness dark. But read the numbers carefully. According to ITU and GSMA data, mobile broadband already reaches around 96% of the world's population. The remaining gap, roughly 300 million people, sits in the least economically viable places on Earth. That gap persists because of deployment economics, not because wireless technology cannot do the job. So what is direct-to-device? It is a satellite system that communicates directly with unmodified, or only minimally modified, smartphones. No dish, no proprietary handset, no external antenna. And critically, D2D is not a competitor to cellular networks. It is an extension of them. The satellite behaves as another layer of the same mobile ecosystem, taking over when terrestrial coverage is absent, damaged, or was never economical to build. Services today range from emergency messaging through two-way texting up to voice and broadband ambitions. To see why this is new, compare it with the satellite phones we already had. Iridium and Thuraya handsets carried the burden. Large antennas, proprietary chipsets, dedicated radio frequency front ends. They cost $500 to $2,000, needed expensive airtime, and served a niche of perhaps 2 to 3 million users worldwide. D2D inverts that model. The complexity moves off the phone and into orbit. Satellites now carry massive phased array antennas, some spanning more than 220 square meters, generating enough gain to close the link with a phone's weak cellular radio. The handset simply transmits on its normal LTE or 5G bands. That single change unlocks the 5 billion smartphones already in people's pockets. The market has settled into 3 broad architectures. First, the satellite as an orbiting base station, operating with a mobile network operator and reusing that operator's terrestrial cellular spectrum. Second, satellite functionality built into specific smartphone models, using mobile satellite service spectrum and custom chipset integration. Third, the standards route. 3 GPP non-terrestrial networks, where certified devices talk to satellites using ordinary 5G procedures. These differ in spectrum, in how deeply they integrate with the core network, in hardware requirements, and in the services they can offer. But the objective is identical: extend mobile connectivity past the edge of the terrestrial network. 4 advances arrived at once to make this possible. Large low Earth orbit constellations cut propagation delay dramatically compared with geostationary satellites. Massive phased arrays and software-defined payloads pushed link performance up by orders of magnitude. Smartphone front ends and modems improved enough to make a handheld satellite link realistic. And 3GPP Release 17 delivered the first standardized framework for placing satellites inside a 5G network. Together, these turned D2D from an experiment into a commercial technology. Here's the landscape today. A ST Space Mobile, low Earth orbit satellites with very large phased arrays, standard smartphones, targeting broadband. Starlink direct-to-cell, SpaceX's existing constellation with cellular payloads, starting at SMS and moving toward voice and data. Link Global, smaller satellites, standard phones, focused on messaging, and the first to commercialize D2D. Apple with Globalstar, a proprietary route using custom silicone and supported iPhones for emergency SOS. And Skylo, geostationary, aimed at narrowband messaging and Internet of Things, rather than consumer broadband. To summarize, D2D lets standard smartphones connect directly to satellites with no special hardware. It extends cellular coverage rather than replacing it. Low Earth orbit constellations, phased arrays, and 5G non-terrestrial networks made it feasible. And several companies are chasing the same goal by very different technical routes. In the next chapter, we look at the radio link itself and why closing it is so hard.